Hi friends. So today we will see, is it the end of generative AI? Have you ever wondered why when you show a video to ChatGPT or any standard vision language model, it takes so much computing power just to give you a simple answer, right? It's because fundamentally almost every AI model today is just guessing the next word. They are auto-regressive. They generate answers token by token, like the cat is jumping. This process is slow, expensive, and honestly, it's terrible for real time robots or smart glasses. But Metafair, Yann LeCun's team just dropped a new research paper called VL-JEPA. This is not a generative model, it doesn't generate text. It thinks. In this video, we are going to decode the technology behind VL-JEPA and why it might change vision AI forever. Let's dive in. First, let's understand the biggest difference. Normal visual language models and large language models like GPT-4V or Llama Vision are obsessed with syntax. They look at image and immediately try to predict words. But VLJEPA uses a joint embedding predictive architecture. It doesn't predict words, it predicts embeddings. What are embeddings? In simple terms, embeddings are the mathematical representation of meaning. Instead of trying to guess the exact English words, VLJEPA predicts the abstract representation of the answer. Think about it. If I flip a light switch down, you instantly notes the concept darkness. You don't sit there debating if you should say the room went dark or the lights are off. The meaning is identical because VLJEPA focuses on the meaning semantics. Rather than specific words, it ignores all the fluff and focuses only on what matters for the task. According to the paper, this makes learning much more efficient because it doesn't have to reconstruct every single surface level detail. So, how does this machine actually work? It has components distinct from standard VLMs. The X encoder, Vision. This takes your video or image and compresses it into the visual embeddings. The predictor. This is the brain. It takes that visual embeddings plus your text query and predicts the target embedding. The Y encoder. This is used during training to encode the text answer into that same meaning space. Did you notice something? No text was generated yet. The entire process happened in silent mode inside the latent space. A lightweight decoder is only used at the very end and only if you actually need to translate that thought into human language. The result? It achieves stronger performance than standard models while having 50% fewer trainable parameters. Now let's get to killer feature. Selective decoding. Imagine you are wearing AI smart glasses. A normal VLM could constantly generate text to process what it sees. You're walking, your battery will die in minutes. But VLJEPA is different. It continuously monitors in video in that meaning space. As long as the meaning doesn't change, it stays silent. The moment something happens, a significant semantic shift, it triggers the decoder according to the experiments. This reduces decoding operations by 2.85x. That means faster response times, less lag, and way better efficiency for real time streaming. Guys, Yann LeCun has always said that generative AI is not the final answer. We need AI that understand the physical world models, rather than models that just spit out text. VL-JEPA is exactly that step forward. It moves Vision AI from being a chatbot to being a true perception engine. If you find this breakdown helpful, hit that like button and let me know in the comments. Do you think thinking AI is better than generative AI? Subscribe for more deep dives into the future of tech. See you in the next one. Thank you, guys.